Again, here's how we define Taylor polynomials. Let's use this formula here to compute specific Taylor polynomials in this particular case. So we want to compute t sub 4, the Taylor polynomial of degree 4, centered at a is equal to 3, for f of x is the square root of x plus 1, and we're going to find it useful when calculating out derivatives to write this as x plus 1 to the 1/2. Okay, so we know that we're going to want to plug in a, which is 3, into f prime, f double prime, f triple prime, and f quadruple prime. So let's start off by computing derivatives. So f of x, we'll just make a nice little table here. F of x is x plus 1 to the 1/2. F prime of x is 1/2 x plus 1 to the minus 1/2. F double prime of x is going to be, bring down that minus 1/2 to get minus 1/4, x plus 1 to the minus 3/2. F triple prime of x is going to be, bring down that minus 3/2 to get 3/8 times x plus 1 to the, I guess that would be minus 5/2. And our fourth derivative here, one more derivative, gives us minus 15 over 16 times x plus 1 to the minus 7/2. Now, we don't need f of x itself. The thing that we care about is all of these derivatives evaluated when a is equal to, at the particular value of a, which here, that is going to be a is equal to 3. So let's do that now. So we have f of 3, f prime of 3, f double prime of 3, f triple prime of 3, and f quadruple prime of 3. And so when we plug in 3, we get 3 plus 1, so that's 4. The square root of 4 would be 2. And then I'm just going to write down the answers as just plug and chug at this point. So 1/4 minus 1 over 32, 3 over 256, and minus 15 over 2048. Let me just do, to make sure that we're good with working with fraction exponents and stuff like that, let me just show off one calculation here. How do we get 3 over 256? So that's going to be 3/8 times 3 plus 1 to the minus 5/2. So that's 3/8 times 4 to the minus 5/2. And so 3/8 times, we can rewrite 4 to the minus 5/2 as 4 to the minus 1/2 to the 5th. We can rewrite exponents in that way. And 4 to the minus 1/2, that's 1 over the square root of 4. So that's 1/2. And so 3/8 times 1/2 to the 5th gives you 3 over 256. Okay, so right now we've got all of these derivatives here, and, the derivatives here in purple. We evaluate them at a is equal to 3 right here. So now let's go ahead and plop everything into our formula. So what are we going to have right here? So t4 of x is going to equal f of a, which is 2, plus, I'm just going to copy down the coefficients real quick. 1/4, so I'm copying all of these numbers here, minus 1/32, plus 3 over 256, minus 15 over 2048. And each one of these, then, needs to be multiplied by x minus a, x minus 3, raised to the appropriate power. So x minus 3, x minus 3 squared, x minus 3 cubed, x minus 3 to the 4th. And then the last thing we have to do is we have to divide out by 1 factorial, 2 factorial, all the way out to n factorial. So dividing by 0 factorial, which 1, divide by 1 here, divide by 2 here, divide by 6 here, and divide by 24 here. And so if we rewrite all of this, we get 2 plus 1/4 times x minus 3 minus, so that's 1 over 64 times x minus 3 squared, plus this crunches out. This crunches out after that 3, cancel with one of the 3's down there, and we get 1 over 512 times x minus 3 cubed. And finally, minus 5 over, after doing 24 times 2048, and canceling out a factor 3 from upstairs and downstairs, 16,384 times x minus 3 to the 4th. So that's an example of crunching out Taylor polynomials. It's basically just using this formula and plopping in everything as appropriate. So just do note that we end up having, so some things to look out for here, we end up having a polynomial of degree 4. Actually, we have terms of x to the 4th. And we are asking this to be centered at a is equal to 3. And so that's why we have all of these x minus 3 squared, so on and so forth terms in there. If I asked this to be centered at some a that's not equal to 3, we'd have an answer that looks different. Okay, so that's an example here. Why don't we end it with a pre-class problem similar to what we just did. Compute a Taylor polynomial. I'm only asking for t sub 2. Center a is equal to 6. For f of x is x plus 2, all of that raised to 1/3 power.